Hello everyone, welcome to our channel Code with Sunny, and in this video we'll be talking about the problem Bob likes invariance of this December circuits 2022. Okay, so I would just recommend you to read this problem at least once. I'm just trying to jump directly to this problem statement by explaining this stuff. So you are given an array V. Okay, so V is an array that would contains n elements. Okay, and vi, like for each element, is always going to be lying in the range from 1 to z. Okay, so you'd be given the value of n and z, where n is going to be the length of the array and z is going to be denote the limit up to which each element is going to have that value. Like each element of the array is going to have the values that would lie in the range from 1 to z. Okay, so you need to find out the total number of arrays. Find total number of arrays of length n, like find the total number of arrays of length n such that v of I must lie between z and 1, and it satisfy, like this is the first condition that needs to be satisfied, and the second condition that needs to be satisfied is like for each m which is greater than or equal to 0, where m is going to be a non-negative integer. Let me just check it out once again. Okay, yeah, for each m which is a non-negative integer, the value, like let me write down this v0 mod. Give me a minute, let me check out once again. Sorry, it would like it starts from m. Let me write down on the next page, that would be better for you. I think I've gone to the previous pages. Okay, so for each I'm just on the case 2, like condition 2. So condition 1 is nothing but vi must be less than or equal to z, greater than or equal to 1, and the condition 2 is for each m which is non-negative integer, m positive, we will just perform this modulus, like m mod which is v0, and then we'll just perform modulus with v1, and we'll just perform modulus with v2, and it goes on up to vn. Okay, and suppose this value is x. Okay, and for any random shuffling of this array v, for any random shuffling of array v, x, like x will be the value you will get, x will be the value you should get. Okay, so if you're not getting it, let me explain you in much more simpler words. So this condition is quite like very much clear, and this condition is like for each non-negative integer m, you just start with this condition, like v modulus v0 modulus v1 and so on up to vn. Suppose you get the value of x, this is the x will be the answer for this operation. Okay, so if you shuffle the array, like suppose you have the array of something like this 1 3 2 4, the like any random shuffling can be 1 2 4 3 also, like it can also be like 3 1 2 4 also. Okay, for any random shuffling, if you perform again m modulus v0, then again modulus v1, and it goes on something like that, you will get the value of x. Okay, if you get some other value, like some other value other than x, it means that this array is not a valid array. Okay, so let me take an example and let me try to explain you how the things will work. Okay, and also you need to report the count of strictly increasing arrays. That's the main point. Suppose we take example as 3 4, so n as 3 and z as 4. Okay, so you need to find out the 3 size elements. Okay, like the array must contain 3 elements, and it is going to be like z as 4, the each element is going to be in the range from 1 to 4. Okay, so what are the possible arrays? So possible arrays, note that you need to account for strictly increasing arrays. So possible arrays is going to be 1 2 3, it is going to be something like 1 2 4 also, it can also be like 1 3 4 also. It can also be like 2 3 4. Okay, so these are the 4 possible arrays that you can have. Note that it should be strictly increasing. Okay, and each element is already lying between from 1 to z. Now you need to check for each m positive, m greater than or equal to 0, non-negative m. If you perform this operation m mod v0 mod v1, okay, you will get the value of x. Then you shuffle the array, any random shuffling will also give the value of x. If any at least one random shuffling will give the value other than x, it means that this array is not a valid array. Okay, so let's try to check it out. Okay, suppose we will pick up this 1 2 3 array. Okay, we have array 1 2 3. Okay, so let's say m is 0. Okay, so it would be something like this: 0 modulus 1 modulus 2, then you have modulus 3. You will get the value as 0. Okay, so if you shuffle this array, okay, so again 0, like 1 2 3 shuffling of this 1 2 3, it can be like let me shuffle this 1 2 3. There is 6 possible permutations for this one. So it would be like 1 3 2. It can also be like 1, like it would be something like this. It would be 2 1 3 2 3 1, or it would be 3 1 2 3 2 1. Okay, so m is still 0, so you will again perform m 0 modulus 1 modulus 3, then you perform modulus 2, again you will get 0. So for m equal to 0, you will get this like all the values as 0. Similarly, for m equal to 1, you will get all the values as x, then all the values will be same for any random shuffling. Okay, so for each non-negative m, like for m equal to 0 as well, m equal to 1 as well, for m equal to 2 as well, and it goes for infinite values. So if you get the same value as x for the current m for any random shuffling, it means that this is a valid array. Okay, similarly this is also valid array, this is also valid array, and this is valid because for this possible one. Okay, actually, so similarly if you take 2 3 4, you won't get a valid array. Okay, like if you can pick out any possible m and you will just check it out, you are not getting the same value. Okay, so only the 3 possible are three possible arrays is going to be the valid array. So the answer for this is 3. Okay, similarly for 3 and 6 we have this 11 as our answer. So let's try to check it out. So n is 3 and z as 11. Okay, so you can see there are a lot of strictly increasing arrays. Actually there are 11 C3 strictly increasing arrays where C is the binomial coefficient. Okay, so what you need to just check it out is there are a lot of arrays. How will just find out the arrays efficiently? So what you will do is you will just iterate from like each element from 1 to z. So you will fix up the first element, okay, and the rest n minus 1 elements will be over here. Then again you will fix up this second elements, and the rest n minus 1 elements will be over here. Then you will fix up the third element, which is, and you will fix up n minus 1 elements over here. Okay, so and first element will be each element from 1 to z. So the last element would be z, and the number of elements for the rest of the elements will be n minus 1. Okay, so it has been found that the elements which satisfy this condition, like m mod v0, m mod v1, will be something of this type. Okay, suppose it starts with 2, then it will go up to 2 4 6 8. It will always go up to the multiples of 2. You can see if you will pick up 3, it will go up to 6 9 12. Okay, and like you will pick up the multiples, and it must not be that the multiples should be consecutive. Okay, the first element will always be the minimum number, okay, of that multiple. Okay, so if you pick up 4, okay, their multiples are actually 8 12 16 20 24 and so on. So first number will always be fixed, which is coming out to be 4, and the remaining multiples can be in any order. Okay, then only this condition will be satisfied. M mod v0, m mod v1, m mod vn minus 1 will be satisfied. Okay, so let me write down in the general case. Suppose let's say the first number is x. Okay, So their multiples will be obviously x into 2, x into 3, and it goes on so on up to such like x into, let's say, y, such that x into y must be less than or equal to z. Okay, so first number is always fixed. Then we have to choose n minus 1 numbers from the remaining multiples. Okay, so if you choose x as note that x must lie between 1 to z. Okay, and you have to choose n minus 1 numbers which are actually, you have to choose n minus 1 numbers from the multiples of x. Okay, so how many multiples of x are actually present over here? So if you have z being the upper limit, then you will divide by x. So let's say this is going to be our count. Okay, so this amount of multiples including x is present, but we have already fixed x over here. So we have remaining multiples as count minus 1. Count minus 1 is going to be remaining multiples. Okay, so our answer is nothing but from count minus 1 you have to choose n minus 1 elements. Okay, so that will be our answer for the current x. Okay, so let's take an example and let's try to understand that. Suppose like z is 11. Okay, and we have this we will just fix up 1 2 3 4 5 6 7 8. Okay, so we'll do 5 over here, then we'll do remaining over here 6 7 8 9 10 and 11. Okay, so we have fixed 1 over here. So what are the remaining multiples for this one? You can see remaining multiples are 2 3 up to 11. Okay, so there are total 10 multiples of 1. So from 10 multiples of 1 you need to choose only 2. Okay, so you need to choose give me a minute, I think 3 and 6. What example that I have taken over here, z as 11, right? Yeah, that's good. Okay, so you need to choose 2 numbers because you need to fill up this n minus 1 numbers because n is 3 and z is 11. Okay, so you need to choose 2 numbers from the multiples of 1. So there are 10 multiples of 1, you need to choose 2 numbers. So your answer is 10c2 for this one. For this 2 you have this multiples as 2 4 6 8 and 10. Okay, so for 2 you have fixed this 2 over here, you need to fill those 2 elements. So you need to pick up any 2 elements from this 4 elements. So you are just writing down 4c2. Similarly, you would be having 3, 6 and 9. So from 6 and 9 you need to pick up 2 elements, so 2c2. From 5 you can see you would be having 5 and 10, only one multiple. So answer for all these elements after that will be 0 0 0. Okay, remember that for this condition to be satisfied, like m mod v0, m mod v1, then mod up to vn minus 1, the number should be of type, like the first number must be a either from 1 to z, like any number from 1 to z, and then the remaining n minus 1 numbers will be from the multiples of the first number. With, let's say the first number is I, then remaining n minus 1 numbers must be the multiples of the number I in any order. Okay, so let's try to find out this value. It was actually 45 and this is actually 6 I think, and this is 1. A 10c2 is 45 and this is 6 and this is 1. So what is the total value? It is 52. So can we have this 52? Can we check this out? If we I think we need to input the test case number also. Yeah, we have one test case, we have 3 and 11. Let's check it out. If the value comes out to be 52, sorry, yeah, 52 is the value that we are getting. Okay, so one more thing that you need to understand, that you need to compute nCr value, like this is by the binomial coefficient. It is nothing but n factorial upon r factorial into n minus r factorial. And for this to be computed, you also need to know the inverse concept using Fermat-Little's theorem and the binary exponentiation. Okay, so for that I am just attaching the link to the binary exponentiation video in the description section of the video, so make sure to watch that also. That would help the concept to be cleared. So let's head over to the code to check it out how this can be efficiently done. So again, this is the binary exponentiation which computes a power b in logarithmic time. So if you are unaware about this, you can check out the description section of the video for binary exponentiation tutorial. And now this is for the inverse calculation, which is using Fermat-Little's theorem. Now you need to calculate nCr value, which is if n is less than r, we are just returning 0. If r is 0 or n, we are returning 1. So otherwise, we just need to compute n factorial into inverse of rn n minus r factorial multiplied with them. Now we have this n and z. Now you need to calculate the factorial values first of all. So fact of I equal to I into fact of I minus 1. We need to take the modulus also. Now we will initialize our answer with 0. And from 1 to z, what we'll do, we'll just find out the number of multiples including the current I also. Okay. So our answer will be nCr of count and count minus 1 because the I is already fixed at the current position. Now we need to fill n minus 1 positions among, and these n minus positions will have any values among the multiples of the current I. So we need to choose n minus 1 numbers from count minus 1 numbers. So if current is 0, we'll just say break because the rest of the values will also give us the same as 0. Okay. Otherwise, we'll add up the answers. Okay. Remember that these numbers will always satisfy this condition m mod v0, m mod v1, where first number is fixed and the remaining numbers are the multiples of the first number in any order. Okay. So if you have any doubts, you can reach out to me through the comment section of the video. And thank you for watching this video. Remember that time complexity is O of n log n, in the not calling it as log n, and z log z in the worst case, because you need to compute the powers of z also using binary exponentiation, and we have this O of z as phase complexity. So thank you for watching this video and do not forget to subscribe.